let's look at what is amplification and attenuation. So if you remember the super heterodyne architecture, I hope you are making your notes. So if you remember the different architectures that we discussed, so there was a symbol which looked like this, right? So this is an amplifier. Okay. So let's look at what is amplification and what is attenuation. So you can think attenuation as an opposite of amplification. So you're amplifying something, you are attenuating something. Okay, you are reducing something, you are decreasing something. So that is attenuation. So amplification, also called as gain. So if you look at this symbol, this is a power amplifier or an amplifier. So P in is the input power, P out is the output power, PDC is the supply. So it can be coming from your phone battery, or let's say if you have a if it's some other device which has a wall supply, then it is coming from that. It's a power, okay, that you're supplying. So this is DC. So PDC means it is a DC supply. So P in and P out are the RF signals. So these are not DC. Okay. So this is not DC. These are all analog signals. Okay. These are RF. This is a DC because power supply. Now what is amplification? It is P out by P in. So output power you divide by P in. So see one more ratio, right? So that's why in dB, I told you dB is so important because it's a ratio of two numbers. See another ratio here. So gain is basically P out by P in. Now let's look at as what is attenuation. So attenuation, it is commonly called as insertion loss in RF domain. Why it is called as an insertion loss? Because let's say if you remember the super heterodyne architecture, I have different blocks like this. Okay. Let's say these are different blocks. Let's say I have inserted this block between, this is, let's say block 1, this is block 3. Let's say I've inserted this block 2 and it is not giving any gain. It is actually reducing the signal. Okay, what is the signal here? It is actually reducing. If my signal is like this, it's actually become like this. So you are inserting some device and it is giving a loss. So that's why it is called as insertion loss, also written as IL. Okay. So how do you represent? Example, a resistor. If you have a simple resistor, it actually reduces your power level. So how is it represented? You represent it by P in by P out. So you take the input power, divide it by output power, and you can see that it is a number which tells you how much is the signal loss. Now we can represent both these in dB. So I given an example. If you take the amplifier example, first one, let's say the P in is 5 dBm. So you remember the dBm representation. This is power in watts, right? That we gave to that logarithmic function where I had this power in watts divided by 1 milliwatt. Okay. So you can actually calculate what was the power in watts, okay, from this, because you know this value is now 5 dBm. Because we have taken power with reference to 1 milliwatt. Okay, so in this example, see P in is 5 dBm and P out is 30 dBm. So what is the gain? Now, if you have to go to the linear units, you have to actually do a division. But here, since it is dB, I don't have to do a division. What is the gain? Gain is P out in dB minus P in dB. So basically, see, it was like this, right? It's P out by P in. So division became subtraction. So what is P out in dB minus P in dB? So you'll get 30 minus 5. That is 25 dB is the amplifier gain. Okay. Same way, let's look at an attenuator. So P in is 26 dBm, P out is 23 dBm. So what is the insertion loss? So insertion loss, so it is P in by P out. So I should do P in dB minus P out in dB. You have to represent in dB scale. So what is P in 26 minus 23? You'll get 3 dB insertion loss. Okay, so this is how you work with the dB scale.
Please click on like and subscribe to our channel and click on the bell icon for regular updates.